So the problem in this case, but also in general, is that when using flexible assemblies, inventor messes up completely geometry and constraints defined in master positional representation of the flexible component and any other positional representation of the component that is defined, which I will try to explain. And this example is done to show how easy it is to get into trouble when using positional representations. There was a very long discussion regarding how to build assemblies that are to be flexible, and there were many ideas in the matter. Some said that components within the flexible assembly should be grounded. There was other approach that they should be free to move anywhere they want. There was also a solution suggesting constraining them to the origin planes. So from my experience, from those approaches, grounding a component works worst, is the worst possible solution. Constraining to the origin planes is better solution to fix the parts of the flexible subassembly in the context of the subassembly. But in general, it is not required, so the components within the subassembly are fixed in relation to this assembly. These problems showed in 201 bug report are related with using of positional representation, and in particular the overridden grounded status of the component, which by the way is not followed when the positional representation is activated, because this cylinder here has indicated grounded status when in the assembly in the flexible state its grounded status is overridden to be not grounded. Now I will show that problems here are not related to ungrounding the component and allowing this set to freely fly around and do whatever the set wants to do inside the component, but problems come from messing up relationships, components position, and data regarding geometry stored in master and in other positional representations of the component. I will prove it by simply using a master positional representation and deleting the positional representation, the other positional representation. And what I will do is I will just unground the component now in the master positional representation. We have only the master positional representation and the component is ungrounded, and the only relationships in this subassembly are defined between the parts. So these parts are free to move. I can freely rotate the cylinder, and as you can see, the relationships between components are still valid, are still being followed within the jack assembly, but the components are allowed to fly around anywhere they want. So there is no grounded status, and the components are not in any way positioned in relation to the assembly itself. I will now save it, and I will now go back to my assembly, and I will fix it. So as we can see, this component does not, let's see, representation. So this component has set master positional representation, and now the constraints that are defined and that force that are defined on the top level, so here, and they are trying to force the piston out of the cylinder, are indicated as conflicting. I will delete those to bring this assembly to the proper solved state. Once I have brought this assembly so there are no conflicting constraints, I cannot, literally I can't destroy the assembly by dragging, by doing whatever. I cannot drag the piston out of the cylinder. I cannot define legitimately constraints that violate the internal constraints of the assembly. So this solution is more or less stable, except once it indicates that the status of the relationship is consistent, it cannot retrieve the status to the proper state. This bug is so old, but this is the problem with the design doctor, that is not following what is happening with the assembly. But in terms of how the geometry is handled, it is now handled correctly. So these components are not grounded within their subassembly, and theoretically, I wish to try, and theoretically I should be able to drag this. I have copied it. I should be able to drag this container out, only it is not easy to grab it because there is nothing I could grab to. Maybe if I do it like that. No, but I cannot remove it from here. So because I am not able to grab this component, I cannot, but I can constrain it. So I will constrain this with that. 0. As you can see, I can now position the assembly in the assembly container regardless of the position of the components within it. So this is not a problem of grounding or constraining or positioning. This problem presented in the 201st bug is related to messing up positional representations geometry when using flexible assembly, and now I will present that using different example. Here is another assembly, number 207. So this assembly uses flexible jacks. Not sure where I am. Let's see. So this assembly uses flexible jacks. These jacks have basically, if we examine this jack has master position representation where this piston can go up and can go out and in, and has two fixed geometry position representation when this is set by the stroke that sets the maximum and minimum length of the jack. So in this case, master is the position which allows element to be flexible, and other position representations are not used for flexibility. They are to present the component in some stationary geometry that doesn't move. This is of course to be used on drawings or wherever I need fixed position. And if we see here, if I make this jack not flexible, I can use fully retracted and fully extended positional representation of the jack to show just two extreme positions. Once I switch to master and I make this component flexible, I can freely drag this jack so to simulate the movement. This is a standard component, and this subassembly is another flexible assembly that has some fixed geometry and a jack that is also flexible in this assembly, so it can not only rotate about the axis, but also it can extend and retract as in the definition of the jack. This is all done in the master positional representation of the assembly. Now I will make it to crash. This jack is now in master position representation and is set flexible, so I can drag it. So I will extend the jack to full, and now having it flexible, I activate fully extended positional representation. As we can see, nothing has changed because this jack was extended by dragging it with the mouse. Now I will activate fully retracted, and as you can see, instantly inventor messes up the positional representation, as when this component is set to flexible, this software is for some reason unable to read the geometry and use it in a flexible position representation because it messes up completely constraints, position, element relationships, everything. But once I make this jack not flexible, everything is fine. Another thing that is just I have activated position flexibility in fully retracted, and instantly this jack went out of the axis, which just a second ago was aligned. If, however, I activate master position representation and I do the same, there is nothing wrong. So it is clearly interaction between positional representations and flexibility, regardless of the fact whether in the positional representation other than master of the subassembly the position of the component is fixed or not. So in this particular case, in fully retracted, this jack has fixed geometry. It cannot be flexible because internal constraints of the jack prevent it from being flexible. But still, inventor is not capable of following proper geometry of the jack. But let's get it back to master and get rid of the problem. Now it is it flipped, but okay, it's fully legitimate. We just change sides. So now I will extend the jack by dragging, and I will show you another piece of art. I will try to apply a constraint to drive this assembly between the axis of this pin and the axis of this axis, so this axis. So to define distance from axis here to there, so to drive this jack from the top level using a value. To do that, I will check the predict offset and orientation option, so to have this value assigned automatically, not to violate the current position of the assembly. I select the axis of the fixed pin. I select the axis within the assembly of this leg, and it reads 1390 millimeters, which is exactly the value of the total length of extended jack, which is fully in limits of the jack. Now I will click OK. So nothing has happened. But now, if I delete that and get it here and get it there, okay, let's see. It was crashing just a second ago. Oh, okay, it's crashing. So as you can see here, applying a simple constraint that follows current distance between axes resulted in assembly being destroyed in totally different area. So currently this flexible assembly is brought out of the constraints that are defined in this assembly, and in particular this jack that is placed there, is the constraints within this jack are not being followed. So these are this constraint, which one? So basically the internal constraints of the jack are not being followed, only because I have applied this constraint here. I will now undo that and I will do it again. So it is done like that. This is in some state, and I will now apply constraint from here to there to drive it. The predict offset and orientation is on, and also show preview is on, and the show preview is making a mess here. As you can see, total disaster. Now I'm not sure what happened now, but clearly it was calculated the other way around, but just a second ago the solution was very different. And now it indicates inconsistent relationship. Just a second ago it was inconsistent with something else, but currently there are ridiculous inconsistent relationships errors that, how stupid it would sound, but currently the assembly is solved properly, but these errors are not justified because this jack is following its internal constraint. Only I can do it like that. So basically, as you can see in this video, this is totally unstable and even though I have used only the master positional representations. If I now try to use other than master positional representation, it continues to break because fully retracted jack now is not fully retracted. So this jack now is not following its positional representation. So this is totally not stable when flexibility, positional representations, constraints, all this does not go together.